This whole session, this whole conference is about disaster resilience. If you're not prepared, prepared, you can't be resilient. So testing the equipment, making sure everything is correct and doing it the correct way so you're not actually damaging the equipment is what the new code is all about, and doing it in a very safe way. So the new procedures are all encompassing. They're all tied together now. Whereas before it was saying you should do this, nobody did. Now you have to do it or you're liable. So the new procedures now are required for safety and maintenance associated with both standard and critical backup power systems. They're in full effect. And I'm sure, y'all see it now. It started as, you heard about it, and it's in full effect now. So we spend almost all of our time now going to engineering firms, doing educational seminars, stuff with Michelle's group, teaching these people that these things are in full effect. And it affects everybody in our power industry. And nothing's grandfathered. So every generator you've ever sold, it falls under this. So you have to go back. You have the opportunity to go back and put all of these things that we're going to talk about on these generators to get them back up to code. Maintenance is an ongoing, non-stop process, and you have to do it right. And that's what the code has changed. So NEC 70, that's for new builds and for updates. 70B has to do with maintenance, which is a huge part of what we all have to do. Every generator has to be maintained and on a schedule. And then 70E is the safety that's related to it now. Used to, these were three separate entities. Now they're not. They are, but if you'll take the time to go to AI and ask, how do these refer to each other in 70.3F, it'll blow you away. They are intertwined so much that people cannot go back and say, oh, but I'm on 2016 code. No, you're not. When they tied it to OSHA and critical, everybody's on the new code. There's no loopholes. You pass go, you do it right. And that's the crux of it. And it was high time that it happened. I mean, I've been doing this 40 years. A lot of you guys have been doing this for a long time as well. And we learn things the way of being in the field. When we first opened a Greco in 1985, we've done things that would scare you, but you do whatever it took to hook up a generator. The power is out. You did anything you had to do to get it done. We all had a lot of alacrity, get her done, and we got it done. But we did things that were extremely dangerous, and undoing it once you did it was a totally different story. So anyway, all of these things is what we learned as engineers, or in my case, MMRE, Master MacGyver Reverse Engineer, being in the field, touching that stuff, breaking that stuff, getting shocked, getting burned. That's how this all came around to fruition. And getting the National Electrical Code, which is National Fire Protection Agency, and the safety requirements, and OSHA all on the same page. 700.3F, y'all see when you sell against, you have to sell something in that is critical. It's just what we'll get into that, what's deemed critical. But that turned into the rest of them. So 700.3F says you have to do these things. You can't alter the system. You have to do it in a safe way. Finally, it was adopted into 70B and 70 and everything else. There's more details in 700.3F though. So understanding these changes and how they're intertwined and how they affect electrical generation systems and the liabilities of nonconformance. Some of you are owners or CEOs or presidents or just head of maintenance or whatever. It's about liabilities. And you can get away with this. The inspectors are still learning. We're training OSHA, all sorts of electrical inspectors, fire inspectors. You have 3 guys that can come to a site now and look at it, depending on where you are. If you're on the Gulf Coast of Texas, where we're from, the largest industrial complex in the world, you've got all of them, down your throat. But the liabilities of nonconformance are huge, and you're okay until you're not. Some guy gets arc flash going into the generator, and he didn't do what this new code requires. You're toast. The cool thing about this is something that was put out by IEEE, and they're the driving force behind enforcing engineers. Engineers are only good pretty much for new builds. When they design something by their creed, they have to design stuff by code. So we spend every day educating these guys to do it right. But if they design it wrong, and you're bidding on something and you see it in the submittal or the one line and you know it's wrong, you're actually liable to say that's wrong. If you accept it, knowing it's wrong, you make yourself liable. So when you see these red flags, because an engineer was ignorant of the fact, they just didn't know that this happened, we have to say, at least in an email or a phone call or something, hey guys, the code's changed. You can't do that anymore. You have to do this. So the more you learn about this stuff, and EGSA is where the rubber hits the road, where you learn these things and how they apply is super critical. But what they did was, they all tie together now. And they tied every one of them to each other, but to OSHA. Nobody trumps OSHA. You can't say, I don't want to do that. You're going to do that. And if something happens, somebody's get hurt, you're toast. Wow, that's dangerous. But you're really looking at it and saying, yeah, that's how we do it. And that's what we've done forever. If you're going to load bank a generator, you come up, you pull the cover off of the thing outside, you bust all of the lugs loose, which you're not supposed to do. Or when the generator manufacturers or the breaker manufacturers found out what they were doing, they're like, whoa, you can't do that. We know that. Now the code says you can't do that. So it's generator manufacturers saying those lugs are not repetitive use. You have to put a label on there that says, this is a one-time use lug. You put your wires in there, you torque it down, you mark it, and it's done. That's what engineers thought was happening. When we told them, when you showed them this, they're like, holy crap. No way. Well, no, you didn't put in a tap box, a docking station to plug in a load bank. What else are they going to do? We thought they bought your box. Well, they don't all do that. I mean, there's a dozen manufacturers of all the tap boxes. And it started as portable generators. We all came from a lot of us from the rental industry. You deploy a generator. How can you safely plug in that generator? But it's morphed into load banking. So I would say over 50% of everything we sell and all the competition are called dual purpose. They're portable generator and they're load bank. But the load bank is honestly the most critical part of it. But it can't be exposed to the elements, and that's just what they do. The lugs that are in all of those generators are meant to take THHN wire, torque it, mark it, leave it alone. Generator tech comes along, he has to load bank the generator. He busts every one of them loose, and he takes the fine thread, portable cable that we use, sticks it in there. You can't even do that. We've been doing it for eons, but it's actually illegal, and UL says you can't do it, but that's what we did. Those lugs are not designed for, they just splay it all apart. So your 10-foot pigtails that you had, your load bank guys, now they're 2-foot pigtails because they got to whack them off every time they do it. Well, it's changed where you just can't do that anymore. If it burns up, we went through the largest power outage in U.S. history. What was the mega snowstorm, you know. All of Texas, Louisiana, Oklahoma, Arkansas, New Mexico, and part of Mexico, no power. You know how many generators failed? It was unbelievable how many fired. Depend on, you know, did they take care of the unit? Did they load bank it? Or a lot of them failed literally at that connection point on the breaker. It burned up because they're repetitive use. A tech can't go in there with a torque wrench and set it back exactly the way it's supposed to be. They can, but typically they don't. Anyway, that's part of the things that make you have to do this, why you have to do this. Everything depends on power. And that's just what we did. Technicians weren't talking to engineers. Salespeople weren't talking to engineers or learning, or the maintenance guys. Just getting, you know, that's one thing great about EGSA is you've got maintenance people, salespeople, engineers, you know, suppliers, everybody getting on the same page. So we can't plead ignorant anymore. We learn all this stuff and we do it again. We're not ignorant. We're stupid. We don't want to be stupid. We want to be smart and do what's correct and safe, you know, not be liable. Some of it starts with engineers, but a lot of jobs that we do now are after the fact. The codes have come in and said, you're deemed critical now. You have to put a generator has to be full size. It has to be, available 24/7. So we talked about this. This is something from Schneider. So manufacturers are literally having to say, you're not allowed to do that. You can't do it. They're not repetitive use. They're one-time use lugs, not repetitive. But the code actually takes it another further and says, you can't alter the system. You can't disconnect and reconnect, and you can't have access to these things. How they all tie together, eliminate loopholes. Loopholes is what so many of our customers and us have dealt with for years. They're very direct references and instructions, very explicit. But one thing about NEC code, it's not written around emergency power. There's certain sections that are, but it's written around all electrical. So when they come in to evaluate a building, it's the whole building. Y'all may just be interested in just the UPSs and the generators and the transfer switch sections and all of that, but it applies to everything. It also, NFPA 110, it provides specific requirements for emergency and standby power systems. It relies on NEC for general electrical safety and installation, and they all refer back to 70B and 70E. So that loop is there. Everything refers back. So there's no way to get around this. So 110 does tie to National Electric Code. And then NEC 70 ties to OSHA. The complementary goals are, while NEC provides the standards for how electrical systems should be easily installed and maintained, OSHA 70E focuses on protecting individuals who work on or near these systems. It ensures that installations meet safety standards to prevent hazards, while OSHA 70E aims to protect workers. This used to be like, you should do this. Now it's you will do this, or you will be held accountable. We don't like seeing crazy things happen, and I'm sure I'm not the only one that's been arc flashed, but it's not cool. You got to be suited up correctly, but so So 70E relies on, helping identifying and mitigating these potential the hazards that are associated with doing this. The work practices, the PE regulations, training procedures. You have to train the techs on this, on how it applies to all of the codes. They have to be aware of the electrical system design, installation practices, and how it applies to what they've got to do. It is kind of a changing kind of thing. There's actually some updates that are coming. Compliance and enforcement. Well, NEC is adopted into local building codes, enforced through inspections and permits. OSHA 70E is enforced through workplace safety audits and inspections. The big guys, we get it all the time. It's just part of what we do now. And if you're working with somebody, a large manufacturer, and you're private label and you're working for them, they will come audit you and they will check what your practice is. And if you're installing generators for 3M, they're going to audit the process that you use to do it to make sure you're doing it to this standard. So the way 70B ties, the maintenance is a big part about what EGSA is. So it provides the best practices for maintenance electrical equipment, including recommendations for following manufacturers' guidelines. Manufacturers have to set their guidelines as well. That's part of where they're tied to this. You have to do this, and if you don't do this, you're voiding your warranty. While NFPA 70B doesn't specifically mandate that manufacturers state what is disallowed, it underscores and mandates that necessary of following manufacturer's instructions, which is currently undergoing a lot of required updates. All the manufacturers are. Documentation and procedures. 70B mandates that proper documentation and procedures shall be placed for maintenance activities. This is code. This is a lot to do from what we've done. We haven't had to keep up with this before. And it includes 70B and also understanding and following all manufacturers provided information on the safe servicing practices. This all started with 700.3F. 700.3F applies to any facility that's deemed critical. And it's not what a lot of y'all would think. Our largest critical facility in the country is Home Depot, Lowe's, Kroger. People think those are critical. It's what's critical to infrastructure to keep a community together. So this whole conference is about being prepared and ready. A disaster, whatever happens, they have to be your things that are deemed critical. And then we've got companies that wouldn't necessarily fall under it, but you go to speak at a Chamber of Commerce on who's deemed critical, and I would highly suggest y'all do that. They're like, well, I'm critical. Well, then you need to do this, whether code says you need to or not. If you think you're critical to that infrastructure, then you need to do this. So basically, if the emergency system relies on a single alternate backup source of power, which will be unavailable during testing, maintenance, or repair, the emergency system shall include permanent switching means to connect a portable temporary power source, portable generator. The big thing is testing. The only one way you can test a generator, that's load banking. The permanent switching means need to connect to a portable or temporary alternate source of power shall comply with the following. Connection of a portable or temporary power shall not require modification. Meaning, no opening any panels, not undoing any lugs, and pulling, can't do it. This is where it all started. Now it's in 70B and 70E, same thing. You cannot go in there and alter these systems. You totally degrade the system when you do it. When you're out at a job site and it's Friday night, 11 o'clock, and you just finish this thing up and you just strip the lug out, it's not a cool feeling. Yeah?
How do these codes relate to equipment that's already in place?
Got to go fix it. This is OSHA. If your techs go out to the field to service a generator, the OSHA part of this says you can't pull that cover off. You can't access to live parts. You have to trap key stuff out. It's a totally different world now. You can't disable the auto start signal because I'm going to be in there working. I don't want it to fire up while I'm in there. You can't do those things anymore. It's what we do to save ourselves. But this is about, everybody. You being liable to make sure that guy did it correctly. He's not going to get fried. Yes.
Is that critical facilities only? Kind of follow up on his. What if it's optional same by restaurant?
No. Now, in this part of it, you can't alter the system. That's all systems. That's everything. This is just where it started. 70B or 700.3F gets more into you have to simultaneously load bank and portable generators, and I'll talk about that real quick. But that part of the can't alter the system, that's what 70E is. You cannot go do that. That's an OSHA. You cannot go pull a cover off in the middle of a yard on the back of a building, and there's a 30% chance of rain, and lay it on the ground, and now this whole thing is open. And that's just how we do it. That's what we've done forever. But I guarantee it, when you did it, you knew it wasn't right.
Well, sometimes no, but just the way you always did it.
No, it is. So change is hard.
How many of us, if we go to a place and when it's time to load test, they don't have a docking station, we just say, no, we can't do it, see, you have to get a docking station.
And that's what's happening.
That's what you're saying we need to do, and liability-wise, it's probably what we should all do. We should all probably not do anything.
So
And what do you do? Walk out with the quote, and say, hey, here's a.
you have to remember, this is an opportunity to sell them the docking station, and your best friend is who? The electrical inspector. You say, okay, here's the fire inspector, electrical inspector. He can tell you what you need to do. Here's a quote on doing it. So it's a big opportunity. I'm educating. I'm bound to tell you what you need to do. Is there a grace period? No, there's no. If somebody gets hurt, you're toast. You have to think about things like that. So tell your guys, they have to suit up. There's certain things they have to do. There's just procedures they need to try. Anything you do to cover your butt. But yeah, it's just, you don't just flip the switch on and everything's changed. It's going to take a while to do it. But those bodies are learning all about it right now. And the engineers are all about it. That's new builds. But there's hundreds of thousands of sites that are out there that have to be updated. The first ones you're going to see doing, that the Texas Municipality Show that's coming up, municipalities. They all know about it now.
Now, you keep going back to OSHA mandates this. Does that mean that supersedes any local or state type building code requirements and stuff? It's all above that.
OSHA is OSHA. It's not a city thing, a county thing. It's a national, thing that's tied to the National Electric Code. So when they did this and they tied them all together like that little stool, that was ingenious because everybody's always found the loophole. Now you can't find a loophole, which is good. Or do we want to find loopholes or we want to do it right? We want to do it right. But it is not as easy as, like you say, just doing it. And some people, I don't have that in this year's budget. Well, get it in next year's budget, but get it in there because the big word is the liability. I guarantee you that the president of a corporation finds out they're doing something that's not to code, not going to be a happy camper. And all the, not all companies, but there's safety guys now. There's safety engineers. There's safety. Those guys are going to know all about it. There's fire guys, safety guys, electrical guys. By tying them all together was a huge deal. But you have to look at it as an opportunity to go back to that customer and sell them something else. But, you know, you can sleep a little better at night knowing it's a safer way of what they're doing. So the transfer of power between the normal source and the emergency source shall be in accordance with 700.12, standard stuff. Connection point of the portable temporary shall be marked with phase rotation. They all have phase rotation monitors in them. Mechanical or electrical interlocking shall prevent interconnection of power sources, which means you can use a trap key or you can use a transfer switch. But you have to have something that says you can do both of these at the same time. I don't know if this has the one line in it, but used to everybody put a trap key on the generator when you're going to do you can't do that in this. If it's deemed critical, you have to simultaneously, at the same time, be able to load bank and have a portable generator hook. If they go down, if the generator, you're in a critical facility, and I've got the generator radiator pulled off, or I'm maintaining or whatever, that portable generator's got to start and come on and back them up. And I have to test that generator now. Well, I can't, if I've got the generator main locked out, there's no way to test it.
Once you get the radiator back together. Is that what you're saying?
Yeah, once it's up and running, the oil's been done, everything, I got to load test the generator. I can't do it.
That's the thing I haven't been able to see where it's, because you got single purpose, dual purpose. Most engineers put in, most everybody quotes the cheapest thing they can. So it's usually a single purpose.
Agreed.
You know, so I didn't know if it actually stated that or if that's just.
It does. It's in there somewhere, but somewhere it talks about simultaneously, which only makes sense. If you put the trap key on the generator, there's no way to test that thing. You can do one or the other, but you can't do both.
So as long as you have a trap key with a breaker in your device.
Yes. A transfer switch is the most common, but you can have an isolation switch in the cabinet and a trap key access. So you can load bank at the same time. Yeah, if you're that service tech and I've got to load bank the generator, well, the only way I can do it is to open that breaker back up on the generator. That means I can't have a portable generator plugged in anymore. So now they don't have backup at all. So what's deemed critical? This surprises a lot of people. So obviously hospitals and healthcare, emergency response, public safety facilities, evacuation, emergency, the shelters. So schools are shelters, big churches are shelters. They're deemed critical. They have to have a generator. And the generator might just be for life safety. But after X amount of time, they have to be able to plug in a full-size generator. If you're a retirement home and you have all these people and their little 25 comes on, well, they can run their breathing machines. But then, like in Florida and Miami, when the storm hit, their breathing machines all worked, but the air conditioning didn't come on. They didn't have big enough generator. They all died of heat exhaustion. So they have to have the ability to plug in a generator that's big enough to power the whole thing. Gulf Coast or any place, if it's a high risk, they've got things that are volatile. They have to keep them cool. They have to keep them hot, whatever it takes. They're deemed critical as well.
Didn't they also mandate before too that it is time to plug in they had to replace a lot of gens too, to be upsized to handle the HVAC loads.
Yes.
Due to that storm.
Yes.
So it wasn't just that they had.
Some of that falls into the state,
Yeah.
and Florida does. Texas hasn't gone that far, but I think it's close to being that way. It only makes sense.
From that HVAC.
Yeah. Yeah. Well, in Florida, they couldn't get the little generator came on and ran the stuff, but then they went to go try and find big generators. Well, they were gone. You can't find them. You can't find all sorts of stuff, cable, anything. So being prepared up front, which is what this is about, being prepared for this. Reaction costs a lot of money, and it's hard to do. Being prepared costs less money, no headaches. Facilities that or services critical to community sustainability. Fueling. I can't read my own stuff. Money, banks, supermarkets, food, water. All these things are what a community has to have to survive. Home Depot, because when that storm hit and we were all down, everybody had to go to Home Depot or the big, that's where you went and got all the supplies you needed to get back up on your feet. They're deemed critical to infrastructure. So the specific items to comply with these new mandates, you have to evaluating, developing, implementing, maintenance schedules. 70B literally is a schedule, and it has to be evaluated. So electrical contractors, some generator distributors, they literally have a team that goes in and they evaluate the whole facility. This building is 40 years old. That breaker needs to be replaced, or it needs to be tested every year. The emergency system and this generator, it could be every 6 months. If it's like 35, 40 years old, it needs to be tested a lot. Or they can say it has to be replaced. If it's a newer generator, maybe it's every 2 years. But in 70B, there's a list for every piece of equipment that has to be tested, how often, and then it's evaluated in a 1, 2, or 3. Personnel have to be trained on all 3 codes and how they all tie together. Obvious thing that's already there was, the correct PPE, the testing equipment and tools, which we'll get into a little more. Not altering the system to perform any of these tasks. You can't take bolts off of a panel and pull it off and go in there and work on it. You can't there's just things that you can't do. And you really need to go to the code, pull it all out, and it is not fun because it's not one for emergency power. You can reference it, and it shows how they all tie together, and you have to look at it. It's not written around us, it's written around everything. There are some 700 2 that will tell you what you need to do, but you have to verify absence of power while allowing power while accessible to electrical connections. We have a thing called a voltage test port that all the manufacturers are supposed to put on before you have access in there. It's just a little, you'll see it in a second. Put your probes in there to verify no power in there, I can go in there. Thermal imaging, this is the biggest part of the whole. There's a whole section just on thermal imaging. Every time a load bank service work happens, they're supposed to thermally image the breaker on the generator. So all generator techs will have thermal guns. Actually, all electricians will have to have it. The utility main breaker, the transformer mains breakers, boiler mains, anything, all those things, they have to be, when they're tested at full load, UPSs, they have to have thermal imaging on them. So you can, it's easy to do the little window, they're inexpensive, and the little thermal gun. Generator distributors are going to make a ton going back. Hey, code requires us to do this. It's, $800 for us to put the thermal image thing on there, there again, an opportunity. Some things you can't see the back of the breaker. So they sell their electrodes, connection points that go on there that read thermal connections, and they take a reading off of it. So evaluating, developing, implementing this maintenance schedules to NFPA 70B specifications. We're going to run out of time. Chapter 9, it provides mandatory scopes, work, and maintenance intervals broken out by product type. There's a list of every kind of product type that there is and how it applies to y'all, and deemed on how it's evaluated. And right now there's not enough evaluation companies going around and do all these evaluations. So you have an opportunity to go do it and charge for it and then sell them the gear. Assessment, which depends on the following conditions: equipment physical condition, how critical it is, and the operating environment. If it's in Miami, down on the on the harbor, yeah, it's going to take a lot more. You're up in Tyler, maybe it's not so.
Not very salty.
Yeah, not very salty, not real critical. Refineries, the Gulf Coast, continuously. Man, they're just really caustic. The equipment condition assessed that the ECA is driven by the highest value of these three conditions. For example, if equipment is designed condition 1 for electrical equipment and criticality, but condition 3 for operating environment, then the equipment would use condition 3 during the assessment. They take the worst case. 70B 4.2 provides clearly defined requirements of what elements the electrical maintenance program shall include. An electrical safety program that addresses the condition for maintenance. It's kind of turning all these facilities like into a restaurant. If you have a restaurant, you have certain things you have to do to keep people safe. And you have a health inspector that comes by and checks it all out. Now you've got 3 potential inspectors that can come in and check your system and find this log. Who's been doing it and are they trained? This is going to take a while for all of this to really sink in, but we're here to stay on the front of this, but it's there and it's happening a lot faster now. Ooh. Inspection, servicing, what tests have to be done, a maintenance, equipment, personnel, documentation, records. There's a lot of documentation that goes into this thing to do it right. It's going to be enforced in some places like Phoenix very strictly. New York probably pretty strictly. Other places it's kind of like it is right now. That inspector, we never see him. So, but you have to be prepared for the worst. A process for incorporating design for maintenance-ability in electrical, installation. So we think about that up front. We think about how you're going to get in here, how you're going to work on this thing, is it safe, make it as easy as possible. And then a program review and revision process that considers failures, findings for continuous improvement. It's a lot. It's a whole lot to incorporate. This is an example of what they do when they go in to do a maintenance. On a generator, in this case, it's a UPS. I don't know how many of y'all still actually deal with UPSs. Anything that's battery storage is it's very heat-driven equipment. If it's condition 1, it's every 6 months. You have to do all these, physical, you have to cleaning, lubrication, mechanical servicing, electrical testing. It's like once a year. If it's conditioned, that's a new piece of equipment. Used, it can be every 3 months, 6 months. If it's condition 3, you've got to do like every 3 months. You have to test the things, or they got to. It's a big deal in battery storage. But when you go to 70B, there's a whole list of every piece that's there: ATSs, disconnects, generator mains, all these things that have to be tested. And I'll tell you what I don't think is in here. you're not allowed to have a load dump breaker anymore. So some of y'all might not know what I'm talking about, but generator manufacturers would put a load bank breaker, a load dump breaker on a generator, which is a real pain to the generator manufacturer because it's a whole nother breaker you put in there. They're actually not breakers, they're load dump switches. They're just made to dump the load in case there's a demand, so they drop the load. But the code says you have to test the main generator output, which is the gen main. You can't bypass it to a load dump switch. You have to test the gen main. And in reality, you don't need the load dump switch anyway, because all of your load banks all have a mode to drop the load and leave the fans running. The worst thing you can do to your load bank is just turn that sucker off while it's hot and running. Crystallize the coils. So you can't alter the system, to perform these tests. So all connections, you all know what a cam lock is the standard. You have to disconnecting these permanent connections for temporary or repetitive testing is not allowed for both safety and system degradation reasons. Applies to initial 70C installations, 70E safety requirements, and NFPA 70 testing and maintenance procedures. All three of them disallow it. The use of specifically designed repetitive or use lugs are allowable. I'm not supposed to be putting Power Temp, but we've got the only patented repetitive use lug in the world. This is the voltage test port. So I don't know where this was when we had portable generators, but you always had to have access to get to the lugs to check the voltage. You're not supposed to do that. A lot of generator manufacturers have the shunt trip. If you open that thing, it shunt trips the breaker. So we're drilling holes and crap and everything in the panels to test the voltage. Well, now there's voltage test ports. You're able to test those. This is around permanent, but it is going to be in the portable realm as well within the next couple of years. So having this access to all these live lugs will go away. They will. A lot of generators already have them. Most people defeat them as soon as they get them, but it'll be on there. But with this voltage test port, you don't have to open anything up. You can check all the voltage from outside the generator, but it also verifies. The big deal with 70B and E is it's verifying absence of power before you pull that cover off. Trap key interlocks. As Europe has more influence over us and most of the higher end electrical gear is built in Europe, they don't allow lockout tagout in Europe. You have to do trap key interlocks, which we call a Kirk key over here. We personally won't use Kirk keys, but you can't do one thing without doing something else. You can't have access to turn the breaker off. Oscillation bypasses and all these kind of things, that's what they're for. But that all came from Europe. Not that we didn't make it better. But you can put trap key interlocks on anything. Disconnect handles, access, disconnects, big breakers, you can put them on anything now. But now that falls into the code with 70E, OSHA. Before it's just, you should do that. We knew it was stupid, so we did it. Now you have to. These are the IR guns and the IR windows. Very simple to put in. That's the one that gets wired in with the thermocouplers. But when you do those tests, you have to keep a log of what you did. And the inspector shows up, he can look at their log and go, yep, it was tested, it was at this temperature, all good. So in conclusion, whoops, we're running over. Learn how the revised codes apply to your products and services. Read between the often really fuzzy lines because it's not written specifically around us, and how to best implement those strict changes. Don't be lackadaisical about taking this seriously or being afraid of upsetting a customer because of added cost. You're helping them and protecting them and your people. It's about safety, and it's for a reason. Watch for red flags. When you see specs, point it out to them. If you see it and you know it's wrong and you just close your eyes, you just made yourself liable. So it's an opportunity for you to help specify as well protect, even more. Protect your customers and your suppliers from making mistakes, as you're considered the SME. You're the people. You went to EGSA and you learned all of this stuff. Yeah.
Once you're done, I have an answer to Kendall's question.
Okay. And then, can't read that for. View these new mandates as an opportunity to help protect your customers, your company employees from very expensive liabilities. So, it's a big deal. We all have a little breathing room until somebody gets hurt. And it's just common sense. Just because it's not in the budget, well, you need to tell them to put it in the budget. You just need, if you can sleep at night, we've all seen really crazy stuff happen in our business. In emergency power, portable generators, load banking, these things, the transformation that's happened over the last 5 years is huge. But now the codes and all these people are all getting together. AI is kind of blowing this up as well. A lot of this came from data center as well, and it's falling into our world as well.
The new NEC 2026 version just came out. Are they touching more on this?
There's a few clarifications. A lot of the things that 2026 has is not really based on this side of it. This is pretty cut and dry, honestly. But there's a few. Any questions? Yay. Oh, hurry, we're done. Go ahead.
Yeah, this is kind of just to get it out there. I don't expect, it's more a rhetorical question, but how the hell do we market this to our customers?
Liabilities. It's code. Here's the code that's changed. They didn't want to put handicap ramps on all their buildings, but they did. It's just part of what, learning to do things better. That's how you market it to them. It's a code. You don't have to sell it. Code did that for you already. You just need to say, this is what code says. We can't go in there and pull this thing apart. And here's why. It's dangerous for our guys. It's degrading your equipment. And now there's a code that says you have to do this. I mean, code is code. I mean, you have to be a salesperson, but you have to, know what's right, to sell it. It's just my job to let y'all know that it's there.